implementing Bcrypt. In this video we're going to be focusing on the implementation of Bcrypt. We are not going to be dealing with the theory, we're just going to be dealing with a real world example. In the next video we're going to be checking out what is Bcrypt, how does Bcrypt work, and the best practices. So right now we're going to be checking an example with Node.js and Visual Studio Code. So we are going to explore its implementation using Node.js and its popular Node.bcrypt.js implementation. You don't need to create a Node.js project. The purpose of this section is to show the common steps that developers have to take when integrated Bcrypt in their backend. So here we have Node.bcrypt.js is installed via the Node.js package manager with the following commands. So we are gonna go to our desktop or whatever folder that you have. I have a folder named JSON Web Token or just JSW. And what I'm gonna do here is I'm gonna right click and I'm gonna open, well, first I'm gonna create a new folder. I'm gonna name it mk and I'm gonna name it test, like that. So I'm gonna go into my test folder. I'm gonna go here like this, and right now I'm gonna open it with Visual Studio Code. So I'm gonna type in code space that, and let's see how. Okay, I created it. So now I am in Visual Studio Code. I can close my terminals and I'm gonna control tilde so I can open my incorporated terminal. And what I'm gonna do right now is, first of all, I'm gonna create a file. I'm just gonna name it app.js, like this. And in my terminal, what I'm gonna do is I'm gonna npm init and then -y so I don't have to answer any questions here. Okay, so now we're gonna install npm install Bcrypt. So npm install Bcrypt, like this, and we press enter, and we should see it in our package.json. As you can see, we don't have anything because it's still loading. And okay, so as a dependencies we have the Bcrypt. Okay, so we can also install JSON Web Token, like that. npm install JSON Web Token. So here we have npm install Bcrypt. Okay, then on an entry point file for the server such as app.js, we create a set of variables to refer throughout the implementation. So we already have JSON Web Token and Bcrypt, and we are not going to be using in this particular video JSON Web Token, but I just wanted to show you how to install it and how to call it. So if you would call it, you would have to const jwt, like this, jwt, and then require it. So we're gonna require it. We're gonna open parentheses, and inside single quotes we would type in JSON Web Token, not jwt but JSON Web Token, and we would save it. So let me see here, and this is the official website, the auth0.com. so where I'm getting this information, I'm gonna leave these links below. But if you can see here, we have an example for MongoDB where we're using Bcrypt here, and also this is from GitHub. This is how you would call your JWT, where they're using var and using const. So JWT requiring, we are requiring, and you have to type in the whole word JSON Web Token. So that is that. And now we should create a server file. I already did, is app.js, and what I'm gonna do, let's make it bigger, okay, with Control plus. So now we're gonna call Bcrypt. So we type in const Bcrypt, like that, and we're gonna require it. So require it we open parentheses, single quotes, and you just type in Bcrypt like that. So what else do we have to do? So here we have three variables: Bcrypt, solved rounds, and plain text password 1. So I'm just gonna type it in. So the next one is gonna be solved rounds, and again we are using camel notation. So this one should be require like that. And what do we have here? Solved rounds. So let me see if they give me the choice for the numbers. I think it was, let me see, solved rounds. Okay, let's just put it 10 by default. And now we're gonna call it plain text password. So it's gonna be plain text password like that, password 1, and we're gonna set it in single quotes or double quotes. I'm just gonna copy this plain text password, and let me see, I'm gonna paste it here, put a comma. Okay, so we have these three variables up to this point. Bcrypt gives us access to an Node.js library that has utility methods to facilitate the hashing process. Solved rounds represent the cost of work factor. We are going to use a random password, the plain text password 1, for example. This Node.js implementation is interesting because it gives us two different techniques to hash passwords. Let's explore them. So we have the technique 1, generate a salt and a hash on a separate function calls. So right now we still have to type in some more code in order for this to work. But first of all, we're gonna go into our package.json, and as you can see, we have this script. So we're gonna just modify it, and inside of the script test, we're gonna type in node, since we're using Node.js, and then the name of our server, in this case app.js. And let's see what's happened if I try to run it. npm run, and the name of the script is this. So let's see what will happen. So we're gonna get some errors because we still need to type some more code. So I'm just gonna clean it up. Okay, and now we're gonna go to our server. So here, what do we have here? Let me see. Oh, okay, and this was not a comma, it was a, we can just leave it like that. From here we have the technique 1, generate a salt and a hash on a separate function. So we already did this part. So now what we are gonna do is basically calling the Bcrypt. So here it's gonna be Bcrypt like this, and okay, to the next line we're gonna be Bcrypt like that, and to the next line we're gonna be using three functions: gensalt, then, and then the catch. Okay, so we're gonna use gensalt. We're gonna open parentheses, and we are gonna have the salt as the only argument in the arrow function. So to the right of the arrow function, we're gonna open a curly braces, and we are gonna have a console.log. What else do we have here? We're gonna have a console.log. We're gonna end it with a semicolon, and inside of the parentheses we're gonna open backticks like that, and we are gonna have the salt colon, and then $, curly braces, and then we're gonna pass in this only parameter that we have here, salt, like that. And then we're gonna return, and what we're gonna return Bcrypt. We're gonna return Bcrypt like that, chain it to the hash, and then we're gonna pass in the plain text password 1 and the salt, and the salt comes from here, from this parameter, this only parameter that we have here. So it's gonna be plain text password 1 comma and then the salt, like this. So this is for the this is for the then function. Okay, so I think I messed it up. Okay, I'm sorry for this is for the then function. Okay, so but for the gen salt, for the gen salt function, what we are gonna do is just pass in the salt rounds, like that. So for the gen salt function, we're gonna pass in the salt rounds. Okay, so below that we're gonna have the then function. Okay, outside of that we're gonna have another then function, and we're gonna open parentheses. What we're gonna do here, okay, pretty much the same, but instead of passing the salt as a parameter, we're gonna pass in the hash, and we're gonna be using an arrow function like this. So to the right of the arrow, we're gonna open curly braces. We're gonna have console, and it's gonna be pretty similar, console.log. We're gonna open parentheses, and we're gonna pass in hash. We're gonna, first of all, we need to open backticks and then hash, like that, and we're gonna open the $sign, curly braces, and then the hash, like this, and we're gonna end up with a semicolon, and we're gonna return Bcrypt. Let me see. Okay, it's gonna be Bcrypt, and we're gonna chain it to the hash. And let me see, well, in this case it should be to the, let me see, they're chaining it, and the salt, they're chaining it to the hash. Okay, we're not returning anything here, like that. Okay, so for the then function here, we are just chaining it to the hash, and for this then we don't have a return, we just have the hash. Okay, like this. So store hash in your password database, and finally we're gonna have the catch function, or your catch statement, like this. We're gonna open parentheses, and we're gonna have an arrow function as a first parameter. We're gonna have the error, and then we're gonna cancel that log, or cancel that error. Okay, cancel that error, and we are gonna pass in the error that message, like that, and we're gonna save it. And now let's see what happens. So remember, in order to make this work, we have to type npm, it was npm run, and then the name of our script. In this case, it was named test by default, but you can name it whatever you want. So let's close it up, and let's go into our app. Let me see, let's make it a little bit small. And as you can see, we have the salt, this is our salt here, and this is the hash, as you can see here. So it's working. Okay, so this is the technique 1, generating salt and hash and separate function calls, as you can see. Okay, so yeah, if I do it again, so if I type in npm run test, let's see if they are the same or they are different. So as you can see, the salt, this one, it ends up in XO, and this one ends up in AD, so they are different. So the hash also ends up in SIG, and this one ends up in FYM, so they are different every time you run npm run test. So using the promise pattern to control the asynchronous nature of JavaScript, in this technique we first create a salt through the Bcrypt.genSalt function. So they're talking about this part here. Okay, that takes the cause salt rounds. So this Bcrypt.genSalt is taking the salt rounds. Upon success, we get a sole value that we then pass to bcrypt.hash along with the password plaintext word 1. So we go into the bcrypt.hash, where is that? Bcrypt.hash. Okay, bcrypt.hash, and we pass in the plaintext password 1 and then the salt. So what else do we have here that we want to hash? Okay, the success of the bcrypt.hash provides us with the hash that we need to store in our DB, in our database. In a full implementation, we would also want to store a username along with the hash in the final step. Notice that we included some cancel.log statements to show the values of the salt and the hash. As you can see here in our incorporated terminal, we have the salt and the hash, and every time you run it, it's going to be different. So if I run it again, it's going to give us a different result, the salt and the hash. And this is because we are using cancel.log salt with inside of backticks, and here for the hash, for the salt we're using cancel.log, and for the hash we are also using cancel.log. So that is that. Okay, something that is really helpful in this implementation is that you do not have to create the salt yourself. The library creates a strong salt for you. In the first run, I got the following results in the command line. So this particular blog of the auth.com website is getting this particular numbers, this particular salt and hash, but ours is going to be different, and every time you run it in your terminal, it's going to give you a different result. You won't be able to reproduce these results again, since the salt is completely random. Every time gen-salt is run it again, I got the following output as I show you with mine every time I run it. Hence, each password that we hash is going to have a unique salt and a unique hash. As we learned before, this helps us mitigate greatly rainbow table attacks. So now we're going to see technique to auto-generate a salt and hash. In this version, we use a single function to both create the salt and the hash and the password. So let me see what is changing here. So let's make a little smaller. Okay, and we're not using the JSON web token here in this particular example, but I just wanted to show you how you would call it. So you would just type in const JWT and then require and then the whole name JSON web token. So here we have the same thing. Let me see. So the password is not changing. Okay, but then we have the bcrypt, and then we have that hash. Okay, so we have that hash, that thing, and then that catch. So the error is not changing, that hash is not changing either. So okay, so we can just okay, I'm just gonna type it in. Okay, like that. So everything is the same, but now we're gonna have that hash like that, and we're gonna pass in the plain text password 1, and then what else? We're gonna pass the salt rounds. Okay, like that. So we're passing the plain text password 1 and the salt rounds. Okay, so now we're gonna use the then function. We're gonna open, let's make it like this. We're gonna open parentheses, and inside of that we're gonna have an arrow function. It's gonna take hash as the first argument, and to the right of the arrow we're gonna have a cancel.log, and we're gonna cancel that backticks, and it's gonna be our hash like that. And we're gonna open $, curly braces, and then the hash like this, and then store your password in the database. And finally we're gonna have the catch. I'm just gonna copy the catch function, so like that. So it'll be that catch, and then you have the arrow function. It's gonna be the arrow to as a parameter, and then the cancel that error. In the parentheses we're gonna pass in the error.message. So we're gonna save it, we're gonna clean this one up, and now we're gonna run it with npm run test. and as you can see we only have the hash. We are not getting the salt, obviously, since we are only cancel that login the hash. We are cancel that login the hash. So this technique has a smaller footprint and may be easier to test. Again, a new hash is created each time the function is run, regardless of the password being the same. Notice how in both techniques we are storing the hash and not the password. The user's password itself should not be stored anywhere in the plain text. Once we have our password hashes stored in the database, how do we validate a user login? Let's check that out. So now we're gonna see the validating a password with a hash. Using the Bcrypt.hash method, let's see how we can compare a provided password with a stored hash. Since we are not connected to a database in this example, we are going to create a hash and save it somewhere like a text editor. The hash I got, and this is the hash that he is getting in this example. And by the way, if you would like to make a backend out of this, you have to install Express, you have to install Mongoose, and then connect it with MongoDB, for example, for the database. But we are just focusing on the Bcrypt. So we have this. Next, we are going to check the password and see how they match. First, we check if our store hash matches the hash of the provided password. So this is the hash. Okay, and let's just okay, so I mean we already, okay, we are calling Bcrypt. What else do we have here? We have the plain text word, the plain text password one, like that. We don't have the salt, so we're gonna take it out like this. And okay, so okay, the plain text password one is the same. Okay, so that is that. What else we're gonna be calling? We're gonna be calling the hash, and the hash is gonna be set to, I'm just gonna copy it, so it's gonna be set to this. So this is gonna be our hash. I'm gonna save it, and now we have the Bcrypt, and we're gonna be using the compare method. So let's just delete the whole thing, and then we're gonna compare method like that. And what else we have after that? We're gonna have the then function, and finally we are gonna have the our catch. Okay, so as you can see we have three functions here. Now in the compare, we're gonna be passing in the plain text password one, that is this one, and then the hash. Let me see. Okay, so we don't have the salt rounds here. Now in the then function we are gonna have an error function, and as an only parameter we're gonna have the res, and we're gonna have our curly braces. We're gonna cancel that log, and we're gonna cancel that log, just res. And finally we're just gonna grab this for our catch. And okay, so we have the Bcrypt, we have the compare, the then, and then our catch. So now let's clean it up, and this time we should return a boolean, and this should be true. So let's run it, and it gave us a boolean true. Okay, in this case res is true, indicating that the password provided when hash match the store hash, so it matched. Opposite, we would expect to get false for res if we check the hash against plain text password 2. So we're gonna add a plain text password 2. I'm just gonna grab it, and I'm gonna go below the plain text password 1. So in line 4 I'm gonna paste it, I'm gonna save it. And what else is changing here? So nothing else is changing, but now if I run it, it should get me false, a boolean false. Okay, let me see hash. plain text word. I save it. Okay, so let's run it. Okay, it's still giving me. Okay, let me see why it's giving me true. Let me see. So plain text password 2. Oh, obviously because I'm passing in the plain text password 1. But now let's change it to plain text password 2. Okay, so now it should give me a boolean false. So let's run it, and there you have it, a boolean false. And effectively res is false. We did not store the sol though. So how does the bcrypt that compare know which sol to use? Looking at a previous hash slash sol result, notice how the hash is the sol with the hash appended to it. So this is the salt and this is the hash, and here this is the salt and that is appended here. Now bcrypt that compare deduces the sol from the hash and is able to then hash the provided password correctly for comparison. That's the flow of using Bcrypt and Node.js. This example is very trivial and there are a lot of other things to care about, such as storing username, ensuring the whole backend application is secure, doing security tests to find vulnerabilities, hashing a password, though essential is just a small part of a sound security strategy. And in this particular video we only focusing on the example using Node.js and using our Visual Studio Code, so we can check out everything in our terminal. But in the next video we're gonna be seeing what is Bcrypt, how does Bcrypt work, and what is the best practices.